Hello everyone. Still now we have covered all the concepts that were given in this chapter 6, that is square and square roots. Now it's time to do a quick revision. Let's do the recap. So first of all, we read about that if a natural number m can be expressed as n square, that is, if m equals to n square, where n is also a natural number. Here m is a natural number, n is a natural number, then m is known as a square number, or we can say a perfect square. So here, if m equals to n square, where both m and n are natural number, then m is known to be a square number. All square numbers end with 0, 1, 4, 5, 6 or 9 at units place. So every square number, if you see, that is going to end with these digits that are 0, 1, 4, 5, 6 or 9. There is no square number that will end with the other left digits that are 2, 3, 7 or 8. There is no such square number that can end with these digits, means these digits at unit place. Now if a number has 1 or 9 in the units place, then its square ends in 1. We can see 1 square is 1. Now next one, if we see that, let's see 11 square, that is 121. Similarly 9 square is equal to 81. So all these numbers that have 1 or 9 at its units place, they end with the digit, their square ends with the digit 1. We saw this as well. There were some other properties, like when a square number ends in 6, the number whose square it is will have either 4 or 6 in units place. That is, a number that ends with 4 or 6 will always have its square ending with the digit 6. You can see 4 square is 16, ends with 6. Square ends with 6. Now 6 square is 36. Again, this square number ends with 6. Similarly, 14 square, you can say it is 196. Again, it ends with 4, or you can even take 16. Both of these, the squares of such numbers, are going to end with the unit digit 6. Now square numbers can only have even number of zeros at the end. Yes, we saw that if a number has 0, only one 0 say, then its square will have 2 zeros. Similarly, if a number has 2 zeros, its square will have 4 zeros. So we can say that a square number can only have even number of zeros at the end. Now square of an even number is also an even number, and square of an odd number is also an odd number. This is also one of the remarks, one of the properties of square numbers, that an even number always have a square also an even number, and an odd number square will also be an odd number always. Then we saw that if we combine two consecutive triangular numbers, we get a square number. We were combining like one triangular number with this consecutive other triangular number 3, we were getting a square number, that is 4, that is equal to 2 square. We saw some more examples for this. Now the sum of first n odd natural numbers is n square. We saw this as well, that the sum of n odd natural numbers, the first n odd natural numbers, is given by this formula n square. If a natural number can be expressed as a sum of successive odd natural numbers starting with 1, then it is a perfect square. So this was one of the method of finding that whether the given number is a perfect square or not. What we did, we saw that whether that number can be written as the sum of successive odd natural numbers starting with 1. How we did it? First step was to subtract 1, then the result, then subtract 3 from the resultant. Similarly, subtract 5, 7, 9. If we get 0 at the end, then that is a perfect square. If we don't get 0, then it is not a perfect square. We can express the square of any odd number as the sum of two consecutive positive integers. If that number is n square, then those two consecutive positive integers are going to be n square minus 1 by 2 and n square plus 1 by 2. This we saw. Now for any natural number m being greater than 1, we have this 2m square plus m square minus 1 whole square, that is equal to m square plus 1 whole square, and here these 2m, m square minus 1 and m square plus 1, they form a Pythagorean triplet. So we did some examples as well where we were given like one of the members of the Pythagorean triplets, we had to find the other members. So we use this information. Square root is the inverse operation of square. Yes, we know that square root is actually the inverse operation of square. Square root is actually the inverse operation of square. Next, there are two integral square roots of a perfect square number. Yes, there are always two integral square roots of a perfect square number. Positive square root of a number is denoted by this symbol. For example is also given. See, 3 square equals to 9 and the square root of 9 equals to 3. This denotes the positive square root, and we are getting this is here. We are getting this square root as 3, which is a positive square root. So this was a quick recap, a quick revision of all the concepts covered under this chapter. I hope that you have understood all the concepts well. You can try the exercise questions. You can take hints from the examples that I did. You can go back to the video lecture that you haven't understood, play it again, watch it again, and do as many questions as you want. We will meet again for the next chapter. Till then, have a good day. Bye bye.